Hi, this is Chong Kim, and we're going to do word search in Clojure. Let's take a look at the input. We have a block of text that we're going to look for these words, and they can appear across, diagonally, or vertically, as well as snaking around. So let's get started. We're going to set this up so that when we save the file, so that's buff write post, and the file is any Clojure file. We're going to go into the shell and run clj on word search, and the input parameter, the argument is the input.txt. So let's start by creating a namespace word search and just print a hello world, just hello. So we save and we see that hello appears, so everything is working. We should check to see if we can get the command line argument. So that is command line args. We see that this is a list. So to get to the actual string, we need to say first. Okay, and we need to read the file, and that's using the slurp command. All right, good. And there's a blank space over here, and that's how we're going to separate the block of text from the list of words. So let's just do a split on new line, new line. So this is a blank line. Now a split takes a regular expression, so you need to put a hash in front of this to turn this to a regular expression. This isn't gonna work because it doesn't know about split. That's because split lives in the Clojure string namespace. So you have to require it. So require from Clojure string. Let's take the split. Now it should work. Okay, good. And this split returns two items. So let's turn this println to a let, and we'll destructure this. So the first item is going to be the grid string. The second one is going to be the word string. Okay, and to check that everything is set up properly, we can just, I'll use prn instead, and prn displays in a different format. Let me see, prn word_s. Okay, so we can see that this looks good. The input string and the grid string and the word string looks good. So let's work on the grid string first. So we want to create a grid line, and we'll start with the grid s. Okay, what we want to do is split this up on the new line. Hash. All right, and we want to separate these into individual letters. We could do that using seek, but that's not what we're going to end up with. Okay, so we can now go through each one of those elements. So okay, so for the first part, we want to turn this. So right now it's each line is a list of characters. But we want to make it look like this. A list and some kind of row and column information over here. The comma in Clojure is optional. it just serves as a white space. So this is where we want the row and column information. Okay. To get the row and column information, instead of using map, we're going to use map index. And when you do that, then the first parameter is the index, and for this, since this is for each line, it would represent the row. And for this one, if you do map indexed, this one would be the column. So you have the row and the column. Okay, this is exactly what we want. We want a list so that we have a line of input. We have the row and column information, we have the character, and it's just a list. And these are all grouped by their lines. Okay, this is good. Okay. The second thing is, the next thing is the grid. Okay, so we just set the grid to be this, and what we want to do is we want to turn this into a map with the row column pointing to a character. Okay, so since this is a list of those cell information, we need to do we need to apply concat to it. Apply concat. If you apply concat now, you can see that it's the same information, except that instead of it being grouped into lines, it's all grouped together. So we have it almost in the right form, and all we need to do is just do the conversion. You can do the conversion by using into. If you say into using the curly braces, that should turn it into a map. And it looks good. So we have the, we can see that the row and column coordinate is pointing to the character, row and column, character, row and column, character. So the grid is set. Next is the words. So let's look at the words. Okay, we need to, this is one string, so we need to separate this by the commas. So you split on the commas. The first problem is that we have lowercase letters, and just to be consistent, we should make sure that all the letters are uppercase. We can actually do that at the very top. Slurp would takes all the input, so we can just do an uppercase on this and include this here. All right. The next thing we notice is that there are white spaces, so we want to strip those out. So there's a trim function. So we want to map the trim function on it. Okay, so now the words look good. We have the list of words. So we're going to go through each of the words, and we have all the grid positions. So we're going to set the mark. The mark is going to be a list of positions where it found the letters. And we're going to create a function called search that will do that. But in order to do that, we actually have to go through some loops. So using a for, if I have A here that goes from 0 through 4, 0, 1, 2, 3, and a B that goes from A and B, we can just create an A and B here. You can see that it loops through. So of 0, A, B, all the way through. So that's how we can have a nested loop. So we're going to create a for loop here using the words. So a word goes through all the words. And we want to go through all the positions. So that's the row column positions. And the row column positions are really the keys from the grid. So the grid has the row column as the key, and if you do keys, you get all of them. So these are all the valid key positions. Now, words over here, it's only being used once and it looks very bare, so I'm just going to bring this down. Okay, so, all right, actually, okay, right here. All right, so, okay, so let's, we're going to call search. Okay, search, in order to do the search, we definitely need the grid. We need to know the current position that we're in. We need to know what word we're searching for, and we need to have a trail. So we'll call it the path. For the path, we'll start off with an empty set, with an empty list. And let's just create just a dummy function here. Search that takes in a grid, RC, a word, and a path. And for now, we'll just return a list with the coordinate 0, 0. And we're going to be looking at the mark. Okay, this looks good. The reason why there's so many of them is because we're going through all of the grid positions. So for each one of these, we get the grid positions multiplied by the number of words that we have. Okay, great. So let's actually write the code now. The first thing is to test is if the word is empty, because as we are going through the word, we're going to pick off each character. So we start with the first character. If it matches, then we'll take that off, and then we'll work on the second character. And then if that matches, we'll take that off until we get to the end. If we end up with an empty string, that means that all of these letters that came before it matched. So that means that if the word is empty, then we want to return the full path because all those row column positions should be included in our result. The next condition would be when it should fail. Okay, so it should fail when if you've already been there. So that would be if you're, I'm just writing this in English, in path, if RC is in path. Okay, the reason why I'm writing this in English is because normally when you want to test for membership, you would think that it would be something like contains, but contains is the wrong function to use. The correct function is sum. So you're going to check if RC, you need to put into a set if RC is in the path. So path is a list of row column positions, and you're checking to see if that's in there. And this is how you would write this. Okay, so if it's in the path, then you should return an empty list because you should stop when you've already been there. Some other conditions. Actually, this should belong on the inside. Okay, this OR condition here. The other condition is if it's an invalid position, if you're out of bounds. And how do you know? Well, if the RC, and you take a look at the keys of the grid. So if the RC is not in the grid, then you know that it's out of bounds and we should stop. The other terminating condition would be if it didn't match. So if it's not a, this is how you would represent the character in Clojure. And if it's not this, or if it's not the grid character, okay, and you will write this as okay, using sum set the character this or the grid based on the row column position. Okay, so what are we testing this against? We're testing this against the first letter of the word, and that is just the first word. Okay, this is not going to pass because it expects this argument here. This is a list of RC positions. This is a list of RC positions. So when you have a character set that you're testing against, this should be a list of characters. But right now, this is just one character. So we need to make sure that we put this in a list. So put brackets around it. Now it's in a list. So everything looks good for this. All right. The next condition, well, actually, you're in the else clause right now. So at this point, you know that the letter matched. And so you need to go on in the next direction. So to go through all the possible directions, I'm going to use a for loop here, R going from -1, 0 through 1. And the column difference is going to be 0, -1, 0, and 1. And actually, I think that's it. And so we're going to continue to search. The grid still remains the same, but the RC is going to be different. So the RC is going to be, you take the first of the RC, and this would represent the row. Okay, let's put that in brackets so that, okay, so that's the row position, and if you do the second of RC, that's the column position. So we're going to add R to this one and add C to this one, and this would give us the new position in the direction that we specified in this for loop. Okay. Then for the word, we know that the first letter matched, so we need to give it the rest of the word. And as for the grid, we're going to add the RC into the path. Okay, so this looks good. Close this up. Okay, and let's take a look at the mark. Okay, the reason why we have all these empty lists here is because when we're doing a search, we're doing multiple searches in this loop, but we don't want a list of a list. We want to, as soon as we get this, we want to gather those lists into one list. So this should turn into one list rather than a list of a list. So you can do that by doing apply concat on this. And let's just okay, it's getting a little long. Let me just put that there. Okay. There's also another point where we're using search, which is right here. And for that, we also need to do apply concat. Okay, so we got rid of all the nils, the empty lists. So let's see what this looks like. So we need to go through each of the, start with the grid line. We're going to go through each one of those. So we have a line of cells here. And we're going to go through each one of those. Now we have a cell. And the argument that we pass to the map is the line. And a cell looks like this. It has row column information followed by a character. So for those, let's just put a character. And this should look just like the grid. Okay. So you can see that it's a list of a list. We can, since this one is a list, we can join it together with spaces. We're just turning this into a string. Then the outer one, well, let's see what this looks like. Oh, the reason is because we need to also include join up here. Okay, so that looks good. And we need to do a join on the outer one using a new line. Okay. So this is where we're printing out the character, but we want to print out the character conditionally. Okay. So let's put an if condition here. Get rid of this. Okay. So if, and the condition would be, well, we have the RC, and we want to see if RC is in the mark. So you say sum, turn this into a set. So we're checking to see if it's in the mark. If it's in the mark, then we want to print out the character. We want it to be the character. If it's not, then we just put a dot there. Okay, so we can see that everything is working. So this is word search in Clojure.